This video is about the frequently asked questions from section 1 day 1 in Algebra 2. There's not a lot of them, but there's a few. Number 23 sometimes causes people grief. And once again, it's that problem with the most common mistake made in mathematics, not distributing that negative. So this one will give us, we think of this -3 as multiplying, distributing that through the parentheses. 2 minus 3x minus 12 equals 8. And this is usually where people have messed up and forgotten to distribute that -3 through there. So this will give us a -3x, and then 2 minus 12 would be a -10 equals 8. And now we have this 3-stepper down to 2 steps. So we go ahead and add 10 to both sides, and then divide by -3. And every time I do these, I hope you're paying attention to the fact that I'm showing every single step. Even though obviously there are several of these that we should be able to do in our head. You can't do that because when I'm grading tests for you, I have to see every step of your thinking. I can't speak to you and I don't yet have ESP. So I need to know that you are understanding every step in this problem. Then the next one that is a frequently asked question would be going down to the word problems, which would be number 27 and 28. So number 27 says that we have 2 planes that left an airport at noon. One flew east and the other flew west. So the first thing I would do is just go ahead and draw a little sketch to get myself going here. And my little dot there is going to be the airport. And then throw in the information that I know. One flew east, the other flew west. Well, I don't know how fast the one to the east is going, so I'm going to use an x for that speed. And then the other one that flew west was twice that speed, so I'm going to use 2x for the speed of that second airplane. Now, it says after 3 hours, the planes were 2,700 miles apart. How fast was each plane flying? Well, you think, gosh, that's an awful lot of information there. Let's see, we've got a distance, and we have a speed, which is also known as a rate, and we have a time. After 3 hours, the planes were 2,700 miles apart. Now, what I noticed first here is that the 2,700, that's a total. So 2,700 miles is what I focus on. And I think, well, that's a distance. Let's see, I've got a speed and I have a time. And we can go back to some really, really basic science formulas. And this is distance equals rate times time. So I've got 2,700 miles here. And I know the distance equals rate times time. And so far, what I have right here is just the speed of both of those airplanes. So then the other piece that I need to figure out is, how long were they in the air? Because that's going to give me my time. And they told me that. They told me 3 hours. So I'm going to have my rate times the time. And now again, I think, well, how does that fit into this 2,700 miles? Well, that's the total distance. So this is how I'm going to find the distance of the first plane. And this is how I'm going to find the distance of the second plane. And I know if I put these two distances together, it has to be 2,700. So 2,700, my total, has to equal my first plane, which is 3x, plus my second plane, which is 2x times 3. And yes, I'm going to write down even that step right there. So the next thing I would do is go ahead and show that that's going to be 6x. Now, basic algebra from here. So 2,700 equals 9x. Divide by the 9. And x equals 300. And we go back and we look for a label. And we realize in this problem that it was talking about miles and it was talking about hours. So this is 300 miles per hour. So you have to use the length of the rectangle is 3 centimeters greater than the width. Well, I don't know what the width is, so I'm going to make that W. and then my length will be W plus 3. And I want to keep reading to see what they're going to have me do. And it says the perimeter is 24 centimeters. Well, perimeter is the distance around. So what I have to do is either multiply each one of those dimensions by 2 so that I can get all the way around, or I can just write them all down and then add them together to give me, again, that total of 24. I was thinking, how am I going to get that total? So W plus 3 plus W plus 3. And then I want to go ahead and add all my W's together, and there's 1, 2, 3, 4 of those. And then put my 3's together, plus 6 equals 24. And now I have a little two-step equation. So 4W, well, I might as well go ahead and write that minus 6 step up here, equals, and then 24 minus 6 would give me 18. And then I go ahead and divide by 4 and do a little reducing there. So 9 halves or 4 1/2. And in this case, because we're talking about the dimensions, we'd probably want to go ahead and write down that that's going to be 4.5 centimeters. And then you're not done, because it did say what are the dimensions of the rectangle. So what you have to do is remember that the length had to be 3 more than the width. So you just add 3 to that, and that gives you your width and your length. And on ACTs or SATs, they might actually ask you after that, what is the area of the figure? This one did not, so you are done at that point. Another one that gets asked quite frequently is going to be number 33. Number 33 is, get the next page here, area equals 1/2 base times height. And this is a literal equation, so what they want us to do is solve this for height. Well, I would say one of the things that makes students most uncomfortable is fractions. So for me, it always makes sense to go ahead and deal with that and get it out of the way first, to just release some anxiety. So if I want to get rid of 1/2, I need to multiply both sides by 2. So I do that, and I have 2a equals bh. Now to get h by itself, I have to figure out how do I undo that b. Well, this is multiplication taking place here, because when two variables are sitting next to each other in algebra, that means multiplying. To get rid of that, I'm just going to divide. And h equals 2a over b. So there's the answer. So again, when something bothers you, don't necessarily wait till last to work with it. Get it out of the way, and that'll release a little anxiety for you. 37 is an interesting problem. This is a nice kind of challenge problem here, which I don't see as being any trouble for you guys. So the problem with this is we want to get x by itself, and everybody looks at that and says, oh my gosh, it's in 2 places, what am I going to do? Well, you know what to do. You have to get it by itself. So that means what you're going to need to do is you're going to need to divide it out of both of those terms. But the easiest way to do that is just to think of this as factoring. So don't think of it like division. Think of it as pulling that x out in front, basically using the distributive property backwards. If they both have an x, pull it out, factor it out. And now this is multiplication right here. What we see between these terms is multiplication. And to undo multiplication, we divide. So we're going to go ahead and divide both sides by a plus b. So x equals c over a plus b, because those two a plus b's will cancel right out. So again, sometimes we use things from the past in math to properly do the problems that we see later on. And this is an example of that. That's the end of the frequently asked questions for this section.